Hi, in this video we are discussing the previous NEET questions from the chapter Thermodynamics which were asked from 2020 to 2024. Question number 1. For the reaction 2Cl gas giving Cl2 gas, the correct option is option number 1, delta RH, that is enthalpy of reaction, is less than 0, and delta Rs, that is entropy of reaction, less than 0. Option number 2, delta RH greater than 0 and delta Rs greater than 0. Option number 3, delta RH greater than 0 and delta Rs less than 0. Option number 4, delta RH less than 0 and delta Rs greater than 0. See, here the given reaction is 2Cl gas gives Cl2 gas. That means the forward reaction is accompanied by bond formation takes place between two chlorine atoms. We know during bond formation energy will be released, so the forward reaction is an exothermic process. So here the delta H is negative. Also during the forward reaction, the number of gaseous particles decreases because two chlorine atoms are combined to form only one chlorine molecule. So during forward reaction entropy decreases because number of particles decreases. So delta S is negative. So in this reaction delta H is negative and delta S is also negative. So here the answer is option number 1. Now question number 2. If for a certain reaction delta RH, that is enthalpy of reaction, is 30 kJ per mole at 450 Kelvin, the value of delta Rs, that is entropy of reaction in bracket joules per Kelvin per mole, for which the same reaction will be spontaneous at the same temperature, is option number 1 70, option number 2 minus 33, option number 3 33, option number 4 minus 70. Listen here. According to Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S. Here delta G is a free energy change, delta H enthalpy change, T is a temperature in Kelvin, and delta S is a entropy change. For any spontaneous process, delta G should be less than 0 or negative. That is, delta H minus T delta S should be less than 0 or negative. Therefore, delta H should be less than T into delta S, that is delta H divided by T should be less than delta S. Here delta H is given as 30 into 10 raised to 3 joules per mole and the temperature T is equal to 450 Kelvin. Therefore, 30 into 10 raised to 3 divided by 450 should be less than delta S, that is 66.6 joules per Kelvin per mole should be less than delta S, or delta S should be greater than 66.6 joules per Kelvin per mole. So here the answer is option number 1, that is 70, which is greater than 66.6. Now question number 3. At standard conditions, if the change in enthalpy for the following reaction is minus 109 kJ per mole, the reaction is H2 gas plus Br2 gas gives 2HBr gas. Given that bond energy of H2 and Br2 are 435 kJ per mole and 192 kJ per mole respectively, what is the bond energy in bracket kilojoule per mole of HBr? Option number 1 368, option number 2 736, option number 3 518, option number 4 259. Listen here. We know we can calculate enthalpy of a reaction from the bond enthalpies of both reactants and products. That means the enthalpy of reaction delta RH is equal to sum of bond enthalpies of reactants minus sum of bond enthalpies of products. Here in this reaction H2 and Br2 are the reactants and HBr is a product. So delta RH is equal to bond enthalpy of HH bond plus bond enthalpy of Br bond, the whole minus 2 into bond enthalpy of HBr. Here enthalpy of reaction is given, which is equal to minus 109, that is equal to 435, that is a bond energy of H bond, plus 192, that is a bond enthalpy of Br bond, minus 2 into bond enthalpy of HBr. So bond enthalpy of HBr is equal to 435 plus 192 plus 109 divided by 2, that is equal to 368 kilojoule per mole. So here the answer is option number 1. Now question number 4. For irreversible expansion of an ideal gas under isothermal condition, the correct option is option number 1, delta U is equal to 0, delta S total is not equal to 0. Option number 2, delta U is not equal to 0, delta S total is equal to 0. Option number 3, delta U is equal to 0 and delta S total is equal to 0. Option number 4, delta U is not equal to 0, delta S total is not equal to 0. Listen here. Since the given reaction is an isothermal process, its change in internal energy delta U should be equal to 0. As it is an irreversible process, it will definitely be a spontaneous one. We know for all spontaneous process, delta S total should be greater than 0. That means delta S total is not equal to 0. So here the answer is option number 1. That is delta U is equal to 0 and delta S total is not equal to 0. Now question number 5. We show the following PV curve, that is pressure volume curve, represents maximum work done. Here 4 different pressure volume curves plotted under isothermal condition are given as 4 different options. You can see these options in the screen. We need to identify the curve which represents maximum work done. Listen please. Mathematically, the pressure volume work against a constant external pressure P external during an isothermal irreversible expansion or contraction of an ideal gas is given by the expression W is equal to minus P external into dV, where dV is called change in volume. That means final volume V2 minus initial volume V1. Please note that here the external pressure exerted on the system is a constant. If the external pressure changes during compression, in order to get the total work done, the equation number 1 must be integrated between the limits V1 to V2. That is W is equal to integral of V1 to V2 of minus P external into dV. If a graph is plotted between pressure and volume between the initial and final state, we will get a curve which represents the work done during the transition from one state to another state or during the compression of a gas. The larger the area under the curve, greater will be the work done. So here the answer is option number 3. Then question number 6. Which amongst the following options is correct relation between the change in enthalpy and the change in internal energy? Option number 1, delta H is equal to delta U plus delta nRT. Option number 2, delta H minus delta U is equal to minus delta nRT. Option number 3, delta H plus delta U is equal to delta N into R. Option number 4, delta H is equal to delta U minus delta nRT. Listen, the relationship between change in enthalpy delta H and change in internal energy delta U is delta H is equal to delta U plus delta nRT. Here delta N is a change in number of moles, that means number of moles of gaseous products minus number of moles of gaseous reactants. Here R is a gas constant and T is a temperature in Kelvin, so here the answer is option number 1. Now question number 7. The work done during reversible isothermal expansion of 1 mole of hydrogen gas at 25 degrees centigrade from pressure of 20 atmosphere to 10 atmosphere is given that R is equal to 2 calories per Kelvin per mole. Option number 1, 0 calorie. Option number 2, minus 413.14 calories. Option number 3, 413.14 calories. And option number 4, 100 calories. Listen, for an isothermal reversible expansion of a gas at constant volume, The total work done W is equal to minus 2.303 nRT log P1 by P2. Here n number moles is equal to 1. R is given as 2 calories per Kelvin per mole. Temperature T is equal to 298 Kelvin, that is 25 degrees centigrade. Initial pressure P1 is 20 atmosphere and the final pressure P2 is 10 atmosphere. Substituting these values, the equation becomes W is equal to minus 2.303 into 1 into 2 into 298 into log 20 by 10. That is equal to minus 2.303 into 2 into 298 into log 2. We know log 2 is equal to 0.3010. So here the final answer is minus 413.14 calories. So here the answer is option number 2.